Greetings, educators. As shared and discussed in my previous video, I want to get to the application of implementing a plan and making an objective come to life and to help students to reach the learning objective set forth for the day, or in this case, for the week. So here I'm looking at week 1, and my objective for that week is for students to be able to interpret systems of equations graphically. And some key points, some things that we're going to do as a learning community would be to write equations to represent graphs, compare and contrast lines in the graph, and use data from the graph to make some predictions and estimations. Even prior to graphing, we could probably start to do that and being very analytical, using some higher order thinking skills as a means to develop our students' understanding about the concepts. So the website that I'm sharing with you today is called Delta Math. It's been a website that I've been using for many, many years within the profession. I'm going to leave 2 very important links in the video. Here I'm not going to explain how you set up and use the website. Someone has already done that for us, and one particular link gives a very detailed explanation how to set up Delta Math as an educator, as a teacher, input in your classrooms and periods, so forth and so on. So please take a look at that video. It's very helpful. How I would use something like this in my classroom would be very, very simple, but effective. Now, I would start by, based upon where we are in the lesson and based upon my students' understanding, if we've been doing this for a while and the students have some great background information, I would most definitely start with just visually analyzing these equations to begin to have students tell me certain things about the equations before we start to graph. And some of those things would be related to if the equations are written in slope-intercept form. If they are, then why are they? If they aren't, what do we see that causes you to think or believe that they are not? I would also start to look at the similarities and differences within the equations, getting the students to begin to think on a higher level, especially in terms of what would make these equations possibly intersect or not intersect. Once we go through those critical parts, then we can start to graph, because we've established some background information, we've established some important data and information that would help us to be successful with solving the following systems of equations graphically on this coordinate plane. If we take a look at that first equation, we see that the y-intercept is positive. So here we will place that dot on 6. And now going back to popcorn style, or even getting the students to generate some responses based upon, well, I don't see a slope. Is the slope positive or negative? What indicators are present to help us to continue to solve this system by using a graph? They'll come up with, well, it's a positive slope, move up 1 and to the right 1, and then we plot that line. If everything is correct, we move forward. With the second equation, this would be a great opportunity to really see what students know by analyzing that -6 and starting to speak about why that's critical and why it may be different than the previous equation, Once they've identified that Y-intercept, again, a great opportunity to talk about the vocabulary associated with these equations in the graph and with this particular standard. We see that the Y-intercept here in this equation is -6. Based upon how you teach it, it can be taught in a multitude of ways, whichever way works best for your students. We can begin to start to graph the slope, rise over run, change in y over the change in x, bringing in that very important vocabulary that will help lead to the mastery and fluency of the standard. A great idea would be to let's start to move up 3 and get our students to begin to question why that would be correct or incorrect. It may be move 1 to the right and start to have students build a pair share or stop everything and right type of opportunity, just to have that check for understanding, and then possibly now going back and doing it the correct way, right, down 3 and 1 to the right, and seeing if that works, and giving the students the opportunity to again stop everything and jot or write, have a pair share, do some form of checking in with students to see if we're all on the same page. And once that's graphed, we can now begin to analyze this point of intersection. We can have conversations about if these equations represent the same line, do these equations intersect, are these equations parallel, so forth and so on. Clearly we can see they aren't, but it's advantageous to begin to have students have conversations centered around the learning. Once that's done, the last great feature of this program is giving students feedback. So if they type in the correct coordinates, I believe I need, okay, it's gonna, we have 3 to the right left and 3 up, 3 positive, -3, +3, submit that answer. And it's just, again, a great check for understanding. If you're in front of students, do we agree? Having that opportunity to build that conversation before proceeding. If it's yes or no, let's see. So it gives us that feedback. That's very important. The lines intersect. Here's the graph. Here's the solution. Fabulous, fabulous way to implement, to integrate technology into your lesson. Check out the links, subscribe, and continue to be the positive, influential educators that you are. Thank you, and I'll see you next time.